Well, let's go ahead and start a little early because I'm a DBA and I like to talk. That's what we do because usually nobody's listening to us, so it's to ourselves. So I'll have the tendency of possibly getting a little wordy and probably using up the extra 2 minutes we've got. We've got an hour here, right? Is that my understanding? Okay. All right. Sounds good. The approach I wanted to take in this talk was one that was really to go ahead and explain why DBAs by nature are kind of crotchety and maybe prone to violence against themselves and others, maybe a little antisocial. And it's because we're really big into order and things working right repetitively and not having to work too hard, but finding a way to make it look like we're constantly working. We're the types that will go ahead and maybe find a shirt that we like and we'll buy 5 of them all in either the same or maybe like 2 colors, blue and black. We like to go ahead and make sure our days are the same every day, day after day after day. And that sounds boring to a lot of people. We love that. We love that. So today what I'm going to go into is, what is it that we're primarily focused on as DBAs when it comes to possibly things that we deal with or we need to collaborate with along with the development side of things. So that's what we're looking at doing here today. Just a brief little bit about myself. I found out about Code on the Beach through Paul Irwin, who is running Code on the Beach and now Code on the Sea. He came to our SQL cruise that I put on earlier this year out of Miami, and we do those 1 or 2 times a year. There's Paul right now. We're doing the Caribbean again this year, or 2015 in February, and then we're going to try the Mediterranean out as well in June. If you're interested, I've got cards, business cards, SQL Cruise cards, stickers, things like that up here afterwards. But we're here to talk about Code on the Beach and support these guys. Awesome group of people. Who here has come previously to other events here for Code on the Beach? Okay, so fair mix of new people. So this will be great. I do consulting. I've been a SQL Server MVP since 2009. I blog at the SQL Agent Man. I also am a board of director for the primary organization for SQL, which is the Professional Association for SQL Server. And then I do twice daily or twice weekly blogs at SQL Server Pro magazine, and then have written a book on dynamic management views, as well as do tips at MS SQL Tips. So I tend to write a lot, and I tend to also think about these things. So primarily what we're focused on as DBAs is performance and security and life's great mysteries. Life's great mysteries like who would win in a fight between, say, Neil deGrasse Tyson and Neil Patrick Harris, that sort of stuff we think about. So today we're not going to worry about talking about those things. We're going to look at 2 topics in a bit of detail. We're going to look at performance-based topics that we're concerned about, and also look at security. This mainly comes out of my experience for 15 years as a database administrator for a medical system up in Michigan. Pull out the Michigan map right here. I was talking to Richie, who now since moved, oh, he's in the back row, okay. Good place. That's where all the unruly kids go. So mainly coming from my experience as a database administrator for the health system that I work at, the environment there I started there back in 1999 as a Access developer. I'm probably skeeved out more than you are right now about that. But the whole Y2K thing was going on, and they needed people, they needed basically to throw bodies at about 4,000 access for applications, databases, whatever you want to call them, to get them into Access 97 so that they wouldn't basically shut down the hospital with all these things. Y2K came and went, no problems at all there, and then they had to figure out what to do with the three of us. One stayed in Access, one went on to be an Oracle DBA, and I went on to be a SQL developer, and eventually got my MCSD, got back from taking that last test, and they go, congratulations, you're our new DBA. So I was classically trained in SQL 2000 and VB6, and now what I thought was going to be happening was just pushing the red button saying go fast, and that was going to be my life from there on out. What it turned into was an interesting case of dealing with going from one SQL server to where we're at now with about 200 of them, from 13 applications that we support that were primarily internally developed to about 2,000 databases where the 90 to 95% of them are purchased from outside independent software vendors. And seeing all the things that kind of go against best practice from a security side and from a performance side inside the database. And so that's what we're going to talk about today. By the way, feel free to raise your hand, ask a question throughout. I'll do what I can to go ahead and address those as we go through, and we'll have some time at the end. So performance. First thing that we know about performance is fast enough and fast are two different things, as Heavy Flash can tell us there. Sure, he might be fast, but he's not extremely fast. We're always looking for a way to squeeze a dime's worth of performance out of a penny worth of hardware and software whenever possible. So what we're going to primarily talk about when it comes time for that is going to be these topics. We're going to talk about trying to squeeze seeks into our execution plans versus scans. And we'll talk a little bit about, from a database perspective, what seeks versus scans are. We're going to talk about some of the pitfalls of relying on select star, as well as some indexing do's and don'ts and never do's. We're going to talk about GUIDs. GUIDs are a lovely, ugly thing. And then we're also going to look at what happens when we rely on some of the defaults to do some of our database creations if you were to go ahead and do a SQL install. Some of the things that can go wrong there and what happens. So a little bit about scans versus seeks. Who here is familiar with SQL execution plans? Okay, we got a fair amount of them. When we talk about scans versus seeks, we tend to use the analogy of a phone book. If you're going to scan through a phone book, say you're being told that you need to find everybody whose first name is John. And how are you going to do that? You're going to look at every single entry inside that phone book and see where there's a John. Or it's going to also fail because you got the possibility of a J and you don't know. So really intensive to go ahead and do that. Conversely, if you're being told to look up everybody whose last name is Smith, what would you do? You would go right to the S's. Then you would go down to the page with the Smiths in it. Boom, you've got them all. It's kind of the same way when it comes to scanning a table or an index inside of a database. You want to be able to, instead of doing a record by record read of everything in that table or in that index, you want to be able just to go ahead and jump right to where you need to start reading from and grab what you need there. It's a huge performance gain. Another term that we use a lot when it comes to that sort of thing, to be able to employ a seek, is called Sargability. A show of hands as far as who's heard that term before. Okay, a couple people. So what's surprising here is that it's not an acronym, first of all. because we all love acronyms, but it's a term. Sargability is basically how likely or how able a operation is able to employ something being searchable. So what we've got are certain operators that you'll find in say a where clause that are going to use a seek versus a scan. They're going to be sargable versus those that are not. So what we're looking at there when it comes to those is we've got our sargable operators on one side, and we got our sargable-ish operators over there, some that may or may not add a performance boost when you're doing searching. And I see a couple people writing things down. Don't worry, because we'll have the, if you see something up here on the screen, we'll have a link at the end where you can go ahead and grab that. And I'm not sure, Paul? Is Paul still in here? Okay, Paul's not. Are we going to upload the decks somewhere so that all attendees, whether they're in the sessions or not, can get them, or is that?
I think so, yeah.
Okay.
I think he's going to try and splice in some of the slides back into the.
Oh, great. All right. This is great. I'm making them do editing now by going ahead and adding comments to the talk. So, what we've got here are sargable and sargable-ish operators. Without looping through each one of those, because I'm not sure about you guys, but I hate it when people are talking to you, presenting, and they're reading off the deck, because they're reading off the deck and you've already read it 2 minutes ago, so you've got those up there. There's one, though, that we try to avoid, and it was one that I brought up using the example of a second ago with the phone book, and that's where you're using like with a leading percent. So something along the lines of where column foo, like, single quote, percent, MITH, end quote. So, hey, I want to find out where all of the entries end in MITH. It's going to have to go through, like that phone book, only inside of the database, and it's going to have to read every single record and then scan to the end of that record and see if that entry ends in MITH, instead of simply saying, if we go back here, using one of those operators. If you know you're looking for Smith equals Smith. If you know that it might be you're looking for Smithson or Smithsonian, something along those lines, you could do the where column like single quote Smith and then a percentage sign to get everything where it goes from Smith on through. I'm sorry, I thought I saw a hand go up over there. Oh, okay. So that's your operators for sargability. A little bit about select star. So what can be so bad about select star? Who here didn't think when they were 8 years old that, that man, someday when I'm making the kind of money my mom and dad make, I'll be able to go to the candy store and just buy all the candy I want, or I'll be able to get all the Star Wars action figures without having to save up money for it. Sorry about that. Normally it's other people doing that. This is what happens when you upgrade your Windows Phone to 8.1 early by saying that you're a developer and faking it out. So, and then again, you kind of got the opposite reaction. Hey, I'm 40 years old and I'm in Las Vegas. I'm drunk. Here's my credit card. What can go wrong there? Well, just like select star, that's what happens. Those are both possibly expensive. Sounds like a good idea at the time. But probably isn't. Odds are, if you go ahead and grab your parents' money that they've got on the nightstand and you head out to the candy store and come home with 4 pounds of Laffy Taffy, aside from the fact that it's going to be painful in a couple days, it's probably going to be painful earlier on when your mom or dad go ahead and get their hands on you. So, select star is kind of the same way. We've got issues with the fact that it's expensive, with the fact that it's not always going to be consistent, And when I talk about that, Delta's trying to be nice to me, letting me know when I fly out. It's not going to be consistent is the big thing from a standpoint of applications breaking. So say you do a select star and then you get maybe 5 columns back. You've gone through an upgrade and you've changed maybe something inside the database or inside the application where you've added columns or you've added a change to the structure of the application. You do a select star now, and maybe where you had 5 columns in a table, you've added 2 columns. That's going to end up breaking your code when it comes back, or the exact opposite. You've added functionality for 4 more columns inside of your application, but you never changed the database. And now what's going to happen is you're going to get a situation where you're trying to bring back information that doesn't match up with your application. So that's a problem with select star. From a standpoint of performance, what you're doing is possibly bringing back more information than you need. So say, and I'll go ahead and say it, you're, actually meaning we take the easy way out and we throw select star into our code. What's possibly going to be the case is I didn't need all those columns. You know, maybe I'm going against a really wide table that's got 40 some odd columns in it, and I just didn't want to take the time to go ahead and itemize out all the columns in my call. Never happens. Never happens. 50% of the time. But what is going to happen now is all your operations for a database perspective have to be done in memory. So if something that you need is not up in the buffer, it's got to go out to disk and bring that information in. And if you're dealing with some systems where you've got maybe only 4 gigs of RAM on the server, you're already losing 2 to 3 gigs of RAM for the OS and some non-database operations. You're left with 1 gig of RAM worth of information, and you're constantly going up and bringing things in, paging out, and you're going to get into a performance issue there. When possibly you only needed maybe 5 of those columns, or 6, or 8 of those columns. Add on to that the subject of indexing, which we're going to get into, and what you're going to end up to is probably ending up in something where you're doing a table scan. If you're doing a select star, instead of utilizing any indexes that could be there to go ahead and search, is just going to say, you know what, I've got to grab everything, I'm just going to read everything in. So I'm going to end up doing a scan. So no offense to my wife, I probably realize now as I look at this that I shouldn't have added the subnotes in there from our cruise back to Alaska, but select star sucks so much. My wife, I love her, and if she hears this recording, you know, it wasn't me. Somebody else typed that in. Speaking of indexing, when we're talking about indexing, we've got some things that I've not only seen, but I've heard, and that I've said myself. Back to that little, just the brief history of you know, where I came from, I kind of went into this whole SQL thing without any knowledge whatsoever of what I was doing. All the training I had for T-SQL was through a Learn T-SQL in 21 Days book to get out of a bad relationship that I was in with my former company. And the access thing happened because I learned enough SQL to go ahead and lie my way into a job interview that I've had for almost 15 years. And so all the stuff that I'm doing now, even 15 years later, I always say that I'm cleaning up the mess from the DBA that was learning on the job, which happens to be me, the same guy. So I'm going back and I'm seeing some of these things that we've done in the past and fixing them now and telling you about them here because hopefully you're not going to get back to my company and tell them what kind of idiot they hired, you know, back in 1999. So there's some bad ideas that come about with indexing. Let's just index everything. If indexes make things go fast, why not just make everything go fast? Can somebody tell me what might be wrong with that idea?
Make your inserts go slow.
Yes, it can make your inserts go very slow. Another comment besides indexing going slow. Who else has something? Richie, you want to add to this?
Your deletes?
Yep. Anytime you're doing an update, you're going to have a problem there. Memory as well. Disk. Indexes take space. What's happening with your updates is every time you do an update of any kind, an update being not just an update, but an insert, update, or delete, it's got to go and not only take care of that information in the table itself, but it also has to do that same operation against the index. So you're making the change in at least one place, maybe two, or more, and we'll talk about that in a second. If you're indexing everything, you might be indexing different combinations of things, and you might end up with one update having to go through not just the table, but multiple indexes to fix things. You're dealing with memory because, as we talked just a second ago, any of these operations have to be done in memory. So you might end up with a physical read off of disk to get that page up into memory in order to make that change, and then it's got to take it eventually back out to disk as well. And then, of course, we've got the space consideration to deal with. And I'm not sure the size of the applications and databases that you find yourself working with, but in some cases, that can be extremely painful. The very last one is one that I'll actually talk about now. We had a commercial application, and I'll go ahead and pick on them because I hate their guts, called Web Extender. Has anybody ever heard of Web Extender at all? Okay, so basically, it's a bad application that does NSA-style analysis of the employees. It basically keeps a track of all the websites they're visiting during work and reports against them. So if you're out and you're looking at cat videos on YouTube, the company knew. If you were out and researching jobs on jobs.com, it knew. And that was going on. Well, we had one table that was roughly, I want to say 5 million rows. I can't remember how big it was. I knew it was massive for the fact that there was only 8 gigs of RAM on the server. And so we had a buffer pool that was roughly about 5 gigs. And the software vendor had 2 indexes on this table. One where it had about 3 columns, I think, if I remember correctly. I'm kind of dealing with some PTSD when it comes to this one. But 3 columns for the sake of our theoretical discussion here. And first of all, one was already a column that was in the clustered index. And we'll talk about the differences between clustered and non-clustered here in a second. And then we had 2 others. And those 2 others were set up so that index A had, we'll say, column 2 in ascending order and column 3 in descending order. And the other index had flipped those, descending and ascending, just to cover all their bases. And this table was constantly read into, or written into, and reads were very infrequent. So based upon that, where it was doing hundreds of thousands of inserts a day, and maybe hundreds or 1,000 reads a day, and they had those 2 indexes sitting out there, what would that tell you about, you know, the need of having that index or those indexes? Probably wasn't worth having around. You're going to be able to get faster performance out of doing your loads in, because if it's scanning all this stuff and it's hung up waiting for the database to catch up with what the application's trying to push into it, you're going to have problems. And if you inconvenience a small subset of reads out of there on a daily basis, you're probably causing more harm than good. People would probably be more likely to deal with waiting more for that subset of activity than what the application was getting trying to do the scanning. But the problem you've got there is is user impressions. So you've got an application that thinks it's slow, but the users might not be seeing that. The users are seeing the reads that are happening when they're doing their, maybe each one of them's doing their 5 reports a day or something. And that's where they're seeing the pain point, so they're saying the application's slow. So there's a tricky balancing act between what you need to do as a DBA or a developer, depending on who's responsible for the indexing, to go ahead and be able to mitigate that. And we've already talked about the fact that indexes take up space. So hey, let's just not index anything. I've seen that as well. So what do we like to see as DBAs? We like it when we look at indexing columns, and these are our primary, this is our focus when we're looking at creating indexes to begin with on a table. We want to find indexes, or we want to index on columns that are being used in seeks, if at all possible, or would benefit a seek that's already going on. We want to look at indexing columns that are used when joining multiple tables together, or used in underlying views in joining tables together. And then also index columns that are used in grouping and sorting operations. That's our primary focus when we look at our indexing strategy. On top of that, you've got the situation of the ability to go ahead and index on multiple columns at the same time as well. And just like that other example that I used previously, you want to balance that out. You want to make sure that you're not looking to satisfy maybe a small subset of operations, or maybe even just making one report go fast by adding an index that might already have something else that's out there satisfying it, where you might just have to tweak the one index. Inside of SQL, there is something called the Database Tuning Advisor that Microsoft had baked in starting in 2005 that will analyze behind the scenes in the dynamic management objects indexes that, based upon the plans that are sitting in the plan cache, would have helped those plans run faster. And 8 times out of 10, and maybe I'm being generous there, maybe it's actually 9 times out of 10. Richie's back there shaking his head, yeah. It's usually recommending an index that either already exists or is just going to satisfy that one thing. The other thing to think about with indexing is, besides the fact that you can index on a specific column or columns, you can even just include the data for other columns in that index as well as something called an included column. So not only would it include the pointer inside to the row ID in the table in this index, but it would also include the actual value of another column inside of there that you might not want to index on. So you could do something along the lines of what's called a covering index, where you build an index that basically allows the call to the database to satisfy the entire call back to the application without ever having to touch the table itself. It can satisfy that entire read right out of the index. One of the ways it does that, possibly, is when you're looking at a clustered index. And what a clustered index is, and there's actually 2 things. There's a clustered index, there's a non-clustered index. A clustered index is going to be the basis for which the data is organized inside the table. It's going to organize itself based upon the clustering key. The interesting thing, too, about the clustered index is that that clustering key, is included already in any non-clustered index that you create. So whereas the clustered index includes the actual value of the clustering key column, a non-clustered index just includes a pointer back to that clustering key as a row ID back in the table, along with the clustered index value. So a lot of times what I end up seeing is situations where we'll have a table that might have 2 indexes on it. Has a clustered index and then has a non-clustered index. And inside of that non-clustered index, not only by through just an implicit structure has that clustering key in there, the developer is also included in that actual clustered index column as a column in the index as well there. So it's kind of overkill at that point. The interesting thing about clustered indexes, besides the fact that it includes the data for that clustering key or clustering keys, because you can have multiple columns in there, is a little bit of a movie question for you here. So can somebody tell me, based upon what I'm going to show you here, what's the other interesting fact about clustered indexes? There can be only one. So you can only have one clustered index on a SQL table. By the way, so this is from Highlander. Show of hands here who knew this when they saw it, just didn't speak up. Okay, if you've not seen Highlander, see it. I'll also recommend another one that's ultra-violent but funny called Shoot 'em Up. If you haven't seen that, great movie. One thing I learned about this, and we'll take an aside here because we're about the 30-minute mark, and we'll lighten it up a bit, is growing up I thought this was an awesome movie. The cinematography is great. It's got Sean Connery. What doesn't suck that has Sean Connery in it, except for maybe the last James Bond movie he did. But I talked this thing up, and then Highlander 2 came out, and I go, oh, gotta go see this. I'm gonna introduce my wife to the whole Highlander thing, starting with Highlander 2. And it would be like, I don't know, the difference between Casablanca and that really bad John Goodman Flintstones movie. It was horrible. It was horrible, and it took me a long time. I had to go to a lot of Julia Roberts movies to make up for that one. But I digress. So clustered indexes. The highest thing, or the thing that I try to look for with a clustered index, that's going to be your primary index, hopefully, when it comes to your table. You're going to want to identify a clustering key or multiple keys, the columns, that have the highest cardinality, the most selectivity, that are most frequently used based upon the access patterns to talk between the application and the database. Those can be either something that's a natural key, meaning that it's going to occur naturally with the data, and there I would think of something that we used to think was appropriate, which was social security number. You can't really do that anymore. Furthermore, not everybody in your database might have a social number. But it might be something along the lines of maybe if you're dealing with something in the automobile industry, a VIN number. A VIN number is going to be unique. It's not going to be repeating, and every value or every record is going to have a VIN number. That's the same way with a clustered index. You can't have any null values at all in the clustering key. It should be unique. And in the case of the VIN number, that would only be probably appropriate if also you're doing a lot of lookups based upon VIN number. If not, then maybe based upon your access patterns for your application, you might try to find another column inside that table that would be appropriate. So that's a natural key. You could also have a surrogate key, and that would just be simply creating an int or big int value column and having it set to auto number, auto increment, and use that as your clustering key. The other thing about that, and I'll speak to that in a second, I wasn't planning on it, is back probably when a lot of us started working in data, we didn't think that it was probably going to explode like it has. I mean, data now is considered big data. And we're dealing with the fact that some of these data types are starting to run out of available numbers. One of the things that a lot of people don't think about in that regard is not just moving to a big int from an int value, doubling the size of, well, geometrically increasing the size of available numbers, but also if you're going to use a surrogate key, start at the negative end. Start all the way back, instead of starting at 0, start back at negative, I can't remember what big int goes to, like 2 billion, or 2.1 billion. 2.1 billion. So start at negative 2.1 billion, auto increment by 1, and you've doubled the lifespan of that column's availability for adding values to it instead of starting at 0. So that's one of those things that I've learned over the years is just because number of lines start at 0, it doesn't mean that you should disregard everything else along the way. So, next topic here. Anybody see that sentence and maybe know why I would say that this would be bad? Besides Richie shaking his head in the back there. Yes?
Because by default, GUIDs are non-sequential.
Ooh, he knew I was talking about a GUID. Yes. So GUID. So basically what we're dealing with there is a auto-generated 16-bit value that, hey, I can just go ahead and do this. It'll be auto-generated. I don't have to worry about anything. The problem we got in that, though, is that when it comes to GUIDs, or GUIDs, however you pronounce it, it's kind of like soda and pop. Up in Michigan, we call it pop. You guys probably call it soda, so we'll say that,
We call everything down here Coke.
Or Coke. OK, there we go. So can I get Pepsi? Coke? Yeah, Coke, Pepsi. What happens is when we're talking about indexes in GUIDs, or GUIDs, or Coke, or Pepsi, is that by nature, whenever you add a value into an index that's based on a GUID, you're already fragmenting that index. It's not going to be sequential. If you're doing index maintenance on a regular basis, you're going to always be touching that index for rebuilds or reorgs, on a regular basis. As a result, because they're completely non-sequential. So we try to stay away from recommending GUIDs, GUIDs, Coke at any time possible. So causes bloating. There we go. We tied in the Coke thing. So GUIDs make you retain water, among other bad things. So that's what we've got as far as performance goes when it comes to that. Now, let's wrap up the whole performance topic with the problem of thinking small. What I'm talking about here is relying on defaults that are set up inside a SQL when it comes to doing things like your initial database setup. So a lot of applications that I've had to take over support for typically fall into one of these categories. We need sysadmin rights temporarily because our application is going to create the default database and create the users, and then after we get that all done, then you can go ahead and revoke our rights from us. Or we're going to give you a script to run, and we'll have you run this script to create this database, and you'll be on your way. Or it's create a blank database for us and we'll populate it. We love that one. We love that one because we don't have to go in afterwards and fix things. And by fixing things, we're talking about things that are going to either be hard-coded into the database creation script or are going to be relied on through use of the model database. So every single SQL instance has a model database. And that database exists as a template for creating new databases. Because you can specify create database foo, and that's all you need to do. At that point, if you don't specify any other operations, it's going to look at the way that the model database is configured, and it's going to create a new database that looks just like the model database. It's going to look at what you've got set up for your default data and log volumes, and it's going to create a database exactly like model. The problem we get into is a couple things. Typically, model is set up so it's like 1 meg. Actually, no, 10 meg, and I think, if I remember correctly, a 1 meg log file. It's set to, the autogrowth settings on it are set to grow at a percentage, so as you slowly add sizes, your autogrowth increments get longer and weirder and exponentially greater. It's going to create it probably in a simple recovery mode, which means that from a backup standpoint, if you're going to be doing backups or restores, you can only restore to the last good database backup, versus if you're running in what's called full recovery, or in some cases with Oracle, a logged recovery. You could restore to a point in time by restoring the last database backup and rolling forward the logs and the log operations to a point in time of failure. It's basically going to look at model as a default and build everything like that. There's ways that the DBAs combat that. We might go in and take the model database and mold it into something that we like. We might set it so that it's always going to be a gig to start off with, and it's going to grow at incremental increments of a gig, and it's going to be in full recovery, and it's going to do this, it's going to do that. The problem we've got, that I've seen at least probably 5% of the time, is that we'll actually get an error if we turn it over to the application code to create things, by the fact that the application code might actually specify a size for the database. And we'll get an error saying that the settings for the model database are too large for the values of the application code that's trying to create a new database, because it actually still goes back and relies on that information that's in model. So what we usually find out after the fact is once the application creates its own database, we're going in as DBAs, we're revoking those database creation or security practices or rights, and then we're going in and we're fixing all these things before we let users connect or testing begin on an application. So relying on the defaults is kind of a rough thing for us. What we prefer, if at all possible, is for the DBAs to in advance create a blank database, get it sized properly to your specifications from the application developer perspective, set up logins. We're going to talk about security here in a second, that work good for security purposes, for best practice, and then turn you guys loose to just get it populated with the tables you need and the structure you need, and everybody's happy. So, security. We're going to wrap this up with security now. We've got a couple things we're going to talk about. So I brought up SA. If this was Oracle, I could say Scott Tiger or system, whatever the default password for system is. I think it's awesome, and by awesome I mean horrible, that relational databases have default sysadmin level logins to begin with, because the job of hacking into that system is already halfway done. Then all you do is brute force a password and you're in with a big hammer instead of a little hammer. So we're going to talk about when to use SA. We're going to talk a bit about server and database roles, specifically how they apply to application use and how SQL or how applications connect to the database. Some do's and don'ts about SQL logins versus Active Directory logins. And then we're going to briefly talk about SQL injection. So can somebody tell me, based upon kind of how you've heard me rant a bit about using SA, a little bit about when we should be using SA? I'll give you a hint. It starts with N. And I heard it there in the front, in almost the front row. Yeah, never. We hate it when we're forced to have something run as the SA login. There's ways around that. I hate to stand up here and say, don't do this without giving some alternatives. So the alternative would be that perhaps we need to go ahead and grant the application, or grant you as the developer temporary permissions to create databases or to create logins. Typically, that's the only thing that we would have to really do to get around this, and then we could revoke those. From a standpoint of applications connecting for all users, maybe doing connection pooling through a SQL login. If you want to ever see a DBA get violent, or by violent I also mean pouty, tell them that they have to run it as SA, that all the end users are going to connect to your database as SA. And the first thing you'll find out from that is that, well, we're going to put you on your own SQL server, license it, and it's going to be really expensive. So you're probably going to be less likely to make sales of your product to companies because it's already going to be expensive because they're going to have to go ahead and put this on its own environment versus sharing something. So there's a couple different roles inside of SQL. You've got database roles and you've got server roles. Database roles, I don't think I need to get into details here, are limited to the database. Server roles are roles that are rights to do things across all the databases on the SQL instance. So we're talking about server roles like database creator, which would have the ability to create databases, or sysadmin to create logins, security admin to create logins. You've got these things that we try to keep limited to only certain operations, maybe temporarily before people get in, or we try to keep them limited just to admins, either from the server perspective or from the database perspective. Database roles, the big one that tends to come up a lot there is DB owner. There's also a implicit user inside of every SQL database called DBO. And basically what that does is it aliases some login as the owner of the database. We try to avoid setting that to anybody that has access that is not maybe a DBA, or we even try to set it to a login that never gets used for anything. Because even though it's inside a database, a DBO aliased individual could take down an entire server. They have the ability to do things to that database that end users probably don't need to do. Backups, restores, dropping the database. One interesting fact that they're able to do is they could add a data file. And depending on how that data file is set to autogrow, or a log file is set to autogrow, they could then add so much data to it that they fill up the volume that's on, taking down a server, even though they don't have rights to do anything at the server level, but being able to modify the database level to go ahead and basically take down maybe a shared SQL instance. So when we talk about do's and don'ts, what we're trying to do there is give them, or give you as the application developer, our customers, our shared customers as the users, the ability to do what they need to do without harming others. First, do no harm is what they say for the Hippocratic Oath inside of the medical environment. So ways around DBO would be doing things like granting DB data reader, which would be a database role allowing the individual or the AD group with those permissions to read from any table. And then DB data writer, which allows them to insert, update, and delete from any table. And then if you're using stored procedures, hopefully you're using stored procedures, because we're going to talk about that next in our next topic, you could grant execute permissions on all the stored procedures, and then that way basically that end user can do everything they need to do without being able to do things like drop the database or maybe drop permissions, things like that. Briefly, SQL versus AD. So the two differences there is Active Directory authentication. It's going to use the login for that workstation and say, okay, I've already authenticated to the environment, so this person I know is this person, and they get these rights. Versus SQL, where it's good old login, password, hackable, nasty stuff. And then there's always the whole hard coding. Nobody here in this room, though, would hard code in logins and passwords into their applications, though, so I don't think we need to talk about that. Except for I see a little bit of an elbow nudge in the front row, so we'll call him out on it. Oh, they're pointing fingers at each other. This is awesome. All right, so yeah, don't hard code logins and passwords. Particularly dealing with medical and PHI and also PFI, regulated data. odds are the passwords that we're being mandated as data professionals to enforce probably don't meet the levels of the hard-coded passwords that you're putting in. And also, there is an audit point for that too inside of a lot of internal audits or even audits through external agencies, because an application would be shared by every customer of your product that you've got out there because it's hard-coded in. So if somebody knows that, hey, application X uses this login and password for them, it's used for you as well. And then our final topic, SQL injection. Who here has heard of SQL injection? All right. Who here has seen this explanation of SQL injection? OK, so good old Bobby tables. Basically, SQL injection is the ability to inject ad hoc Transact-SQL language into your database through the application to do great deal of harm to your data, and also cover up bad grades for Bobby tables. So how it's basically accomplished is through the use of something along the lines of finishing off an entry inside of a text box or something, semicolon, or I'm sorry, end quote to finish that off, semicolon to state that that's the end of a command, and then run another command after it, and there you go. Pass that in. If the application is going to process what's fed into it and maybe run a run SQL task, there you go. So the way around that would be to, first of all, not run ad hoc SQL inside the environment. So don't pass things in and then run a SQL task against those values. You could also get around that by data validation. And then the other option would be to only use stored procedures inside of your application to go ahead and run application code. So those are the three ways around that. So that's it. We've got about 5 minutes for discussion or QA or anything. The text of this will be up on the SQLagentman.com here before the end of the day. At the very top of the page, there's a link where it says presentation files. And this presentation, along with all the other ones I've done in the last few years, are up there to grab. There's information in the deck then too for things like SQL Cruise, a link to the articles that I've written for various places, and if you're interested in SQL Cruise, I've got some information up front, or if you're looking for some database consulting, I've got cards up here as well. We've got 5 minutes, maybe 6 or 7. Anybody have questions? Now's your chance to grill a DBA, poke them with a stick. Yes, sir.
I have a quick question.
Yeah.
You mentioned techniques to avoid SQL injection. What about making a parameterized query?
Okay. So if you're doing a parameterized query and you're popping in, yeah, you could, as long as what you're doing doesn't result in the fact that it's going to take the values that are passed in as parameter and enter that in without validating the data first, that would be a problem if you don't validate the data. But if we go back here for a second, what's basically happening is if you say you're passing this in as a parameter, what happens is it finishes off everything that you've got before that as far as your parameter goes. And then afterwards, these two double hashes are commenting out anything afterwards. So then what you're left with is running, running that.
Same 12, even though you use that.
Yeah.
Okay. That's not true at all. The whole thing's going to be wrapped up in a bound parameter, so the whole thing's treated like a literal var. So the single quote will not say.
Oh, yeah, good point there. That's a very good point, yeah.
So if that block right there were put into a bound parameter in like a piece of dynamic SQL that is in the application, even though the dynamic SQL is technically wrong,
Nope.
there are still a few scenarios where you want to use them instead of a stored procedure. As long as it is wrapped in a bound parameter like that,
You should be fine, that's right.
as long as whatever you're calling doesn't take that and then try to create another SQL statement and then execute it.
Yeah, and see, that's what I was thinking, is the fact that then you would take that, use that, and run it as a run SQL command inside of SQL Server. So yes, that would be a way around it. Thank you very much. I'm sorry, your name?
Justin?
Justin, thank you, Justin. Another question. Yes, sir.
Earlier you showed where you want to have indexes when you're doing joins, and that makes a lot of sense for faster result set.
Yeah.
But you also said in group by and order by, it's an enhancement. I'm kind of curious how it's an enhancement.
Well, if you're doing it inside of a group by or order by, so what's going to happen is as you look at the way that that command's going to be processed, we'll say that you've got a select from where, and then a group by, and then an order by. So what's going to happen first is the results are going to run through, get parsed down through the where clause, so you're left with a filtered full list of all the values. And then at that point, what you've got left is then you've got the grouping operation and the ordering operation. Depending on the columns that you've already, well, no, because what's going to happen is back here, you have to include, I'm sorry, here. So back in the select statement, you can't have columns inside of a select statement that aren't included either as an aggregate function or as the columns that you're sorting or that you're grouping by. So you're already going to have those columns in there. It's going to probably be using an index then to have that. Those index pages are already going to be in memory from doing the evaluation of what you're going to have in there to begin with. So therefore, it's going to be able to use that index because those index pages are already up in memory. Yes?
Yeah, if assuming that your first column is unique, what's the difference between using an include and including the additional columns as part of the index?
Oh, for like a covering? So if you're doing an included column? So if you're, say then what's going on there, so the question is when dealing with included columns inside of an index, and if your first column in the index is unique, what good does that do you? Well, think upon it as if you don't have an included column in that index, but you've got the same index that does have it. And the difference in that is that if you're returning back or you're requesting to do a select on those two columns, we'll say it's only a two-column thing, what's going to happen first is it's going to go into the index. If say it's a non-clustered index, because you can't have a clustered index on, or you can't have an included column in a clustered index. So it's going to hit the index. It's going to identify the row ID in the table where that value is, and it's going to then go out to the table and grab that value and then also grab the value in that row. If you're doing a situation where depending on the columns that you're bringing back, it might, if you include the value, how do I want to phrase this? If you're including the value for those columns, but you weren't necessarily looking at possibly bringing back the value of that indexed column, it was being used maybe as a sort. So you're doing a select column 1, column 2, and we'll say those were both included columns, where the index column equals 42. So it can use the index to find all those rows, and then without having to go back to the table, those columns are already included inside of that index, and it can just satisfy the values from reading a smaller index than going back and reading the entire table. Any more questions? We got time for maybe one more? Yes, sir.
What's your opinion on ORMs? So that's basically going to throw the entire top out the window because...
Yeah. What's that?
Is that another session?
All I will say is that as a database administrator, I would lose my secret hidden database administrator badge if I said anything positive about ORMs. It depends, but my experience with ORMs are not pleasant. And I'll even throw in other applications too that do weird things with the T-SQL in their own way, like crystal reports. Anything that tends to want to hold your head down to the database and say, read it this way, instead of relying on the esoteric way that the query engine works, kind of skeeves out any DBA. So you're not going to find a lot of fanboys or fangirls when it comes to that sort of thing. That being said, though, I've heard tales of uses of ORMs where things actually went decent. But I myself have never spotted that in the wild. So
use responsibly and understand what we've been talking about here, how the query is translated to the plan and execution plan, and understand all that, and understand when you need to use an ORM versus when you need to use SQL.
Yep. Well put. All right. So anybody else have any questions? If so, I will be outside of here because we are 30 seconds from being done. So I appreciate you letting me come in and vent. Hopefully you walked away with some things. And thanks for having me down here. Appreciate it.